answers and how to solve preview 5.1.3. Starting with the first one, 5-24. You've had these same types of problems. Now this is the third day in a row of taking mixed numbers and writing them as improper and going from improper to mixed. So I'm only going to go over 1 and 2. And if you still need to see more examples, go back to yesterday's where I solved 4 more of them. Okay? So again, to take this mixed number and make it look like number 2 that is an improper fraction, I need to take that whole number, so in this case 4, times the denominator, which is 3, because that's going to tell me how many thirds are in 4 wholes. In this case, there are 12. Then I'm going to add that numerator, because we have 12 thirds in 4 wholes, plus the other 1/3, for a total of 13 thirds. Okay? And then I'll go over number 2, which is taking an improper, which is what we just made in number 1, and going backwards and making it into what we started with for number 1. So, number 2, I have 15 fourths. I want to think of, in my head, how many times 14 goes into 15. I should know, well, 4 times 3 is 12. 4 times 4 is 16. Well, it can't go 4 times because that's too big. So, I know it goes into there 3 whole times. And I'll make a note over here. 3 times 4 is 12. So I need to get 3 more to make 15. And again, remember, you cannot put remainder 3. We have to write that as a fraction, which is 3 wholes and then 3/4 more. Here's what you guys like to write as remainder. Here's where that remainder went. We have 3 left, but it's still fourths. Okay? And again, you can try and do 3 and 4 on your own. Again, you can always use that homework help to help you. Next one. Calculate each of the following parts of a part. We talked about the past couple days, the word of with fractions means multiplication. So I'm just going to rewrite this first one here with a multiplication sign. Okay? When I multiply that, remember we multiplied fractions straight across. 2 times 3 is 6. 3 times 7 is 21. And we could simplify or reduce that if we want, because I know 3 goes into both of these numbers. So if I take this one and divide it by a giant 1, or in this case 3 over 3, I'm going to be writing on this side, but that's all right. 6 divided by 3 is 2. 21 divided by 3 is 7. There we go. Okay. And number 2 is solved the same exact way, multiplying straight across. I'll let you try and set that one up and figure out how to do that one. 5-26. We're multiplying these numbers together. So the first one I think most of you probably had no problem with. 68 groups of 100. Okay? Most of you probably know the trick of, well, if I multiply 100, I just add 2 zeros at the end of it, which is a fine trick to remember. Okay? Now, we should use that answer to solve number 2. And notice in number 2, they put a decimal point in there now. Now it's 68 hundredths. So I should notice that in the first one, the decimal point, even though they didn't put one there, was after the 8. So really, they moved the decimal point 2 to the left. So here's what I'm going to do. I'm going to write down my same answer for the first one, and I'm going to put the decimal in. And if they moved it 2 to the left, that's what I also have to do in my answer, 1, 2. So now the answer for number 2 is 68.00, or just 68. You'll notice in the third one, they changed one thing up. Actually, 2 things. They moved the decimal point 1 to the right, but they also multiplied by a larger number, in this case 1,000. So if it was 100, it'd be 100.1. They moved that one place to the right. So they moved 6.8, 1 to the left, and they moved the 1,001, 1 to the right. So really, if we're moving 1 to the left and 1 to the right, they cancel each other out. If I take 1 step to the right and 1 step back to the left, I'm back in the same exact spot. So 3 is the same exact answer as the first one. And now let me erase this so I can actually read the words. It says describe in words what is happening to the decimal point in each problem. Well, I kind of just talked you through it. If the decimal point is moving in the actual problem, the decimal point in the answer will move the same number of spots in the same direction. Okay. Moving on to the next one. Draw your own graph paper. Draw a rectangle with the width of 6 and a height of 8. Okay, so I'm just going to roughly sketch it just for our purposes right now. We have 6, we have 8, and it's centimeters. Okay, and it says I'm going to draw a similar one that is enlarged 300%. Okay, so the first question you should be thinking in your head is 300% is how many times larger? Okay, so I'm thinking, well, 300 is 3 times as big as 100%, and 100% would be the original size. So it must be making it 3 times as large. So I'll do the new one in blue here. If I'm making each of these sides 3 times as large, 6 times 3, this new side here then would be 18. And the other side, 3 times 8 is 24. So it would increase quite a bit. Okay? And then it says draw a similar rectangle with lengths that are 2/3 of the original. So I should know 2/3 is getting smaller. It's not going to get larger this time. Okay, so it's going to be smaller than the original. So here's how I'd go about and solve that one. I'd start with the 6. Okay, and I'm just going to draw the same rectangle down here so I don't have to do it on the same one. And I'll do this one in red. If I'm making 6 2/3 as big, I would take 6 divided by 3 is obviously 2, which would be 1/3. So 1/3 of 6 is 2. If I have 2/3, I'm going to double that, which obviously would be 4. So on my new side would become 4 centimeters. Next is 8. 8 gets a little tricky because 3 doesn't go into 8 nice and even. That's kind of a bummer. Okay? 3 goes into 8, 2 and 2/3 more. Okay? If you weren't sure on that, well, you should know that 8 goes into 3 2 whole times because that's 6. Okay? So 3 times 2 is 6. So that's where my 2 came from in my fraction. And then I should know, well, I need 2 more to make 8. So there's my numerator. Okay? And again, if that is 1/3, I will want to double that to make whatever 2/3 is. So I have to double that. So it becomes now 5 1/3. You might be saying, well, how in the world did you double that and get 5 1/3? Okay, well, I'll show you real quick how I did this in my head. I started with the whole number. I know I can take 2 times 2 in my head real easy. So 2 times 2 is 4. So I'm at 4 so far. I still have to then worry about this 2/3. So 2/3, and I have to double that. So I want to times it by 2. Now, to write 2 as a whole number, I write 2 over 1. Okay? So again, now it's just multiplying fractions. 2 times 2 is 4. 3 times 1 is 1. Oh, excuse me. 3 times 1 is not 1. Hopefully some of you caught that. 3 times 1 is 3. Now I just have to make that into a mixed number. 3 goes into 4, 1 whole time with 1 left over. Now I added these 2 together. 4 plus 1 is 5, and then you have the 1/3 left. Okay? That was a tricky problem. Next one. We have a rectangle here that's 3 centimeters long and 6 centimeters long. And she's talking about, she claims that whenever you increase the perimeter of a rectangle, it increases the area. So it wants us to play around with this idea and try and figure out, is this actually true all the time? So number 1 says, she showed the rectangle at right and said, if I make the base twice as long, then the area increases. Okay? So I would, if I were you, I would test this out. If I double the base, okay? So if I take 6 and double it, obviously that becomes a 12 now. So I doubled the base. It does not say that she doubled the other side or the height. Okay? So Now I'm going to find the area. The original area I should have said was 18 centimeters squared, because 3 times 6 is 18. The new area is now 12 times 3, which is 36 centimeters squared. You notice the area doubled because we doubled a side. So she is correct in that case. Now number 2 says she's making now kind of the same claim about perimeter. It says, is her claim about the relationship of area and perimeter correct for all figures? That's the key word here, is all. Okay. So here's an example. I'm going to use her example here of 3 centimeters and 6 centimeters, which we already said has an area of 18. And in case we didn't know, the perimeter of this one is 18 centimeters. Okay? So the area and perimeter are the exact same. If I make another rectangle, and it's 2 centimeters by 9 centimeters, the area is still 18, but now the perimeter is 22 centimeters. Okay? So that's proving that her claim is incorrect. Her claim is incorrect. I made the sides or different lengths. The areas did not change. The perimeters did. So I can change the perimeter without changing the area. So those are the answers to 5.1.3. Good luck.